If you want to take seats, get comfy, get your coffee. Get me coffee. All right. No coffee. Okay, awesome. Awesome, so welcome back. So again, for those of you who might just be joining in from Twitch for the first time today, hi, I'm Zach Parrish, tech artist out at Epic. In this session, we're going to go over some design considerations specifically for mobile. Now, I have a slide deck here. I'm probably at some point going to fade away from it, and I might forget to go back to it, but that's okay. Just bear with me. So some of the things that you care about the most for mobile development are supported right out of the box in Unreal Engine 4. So things like touch control, gesture control, sensor controls, which we're going to be taking a look at live. We're going to build a little tilt-based game using Blueprint to kind of show you how to wire that sort of thing up, as well as online subsystems. So things like leaderboards, achievements, in-app purchases, that sort of thing. Now, most of these bits of functionality are exposed to Blueprint. That means that your artists and designers have access to them without having to actually write code. And only because I get asked this a lot for the programmers out there, yes, if it lives in Blueprint, it automatically lives in C++, because all Blueprint is ever really doing is calling C++ functions anyway. So we're going to start off by taking a quick look at online subsystems. To be perfectly honest, this is not easy to demonstrate live in front of everyone because most of the heavy lifting for online subsystems isn't on us. You're going to do a lot of the hard stuff. Well, I say hard, it's really not that bad. On the Google Play or iTunes Connect side. So that's where you're going to set up, of course, your app ID, any of your leaderboard identification, your achievements, and so on and so forth. Once you get all of those set up on the far side in Google or Apple's site, then you're going to use your project settings, which we looked at earlier. It's under platforms, to make the associations, right? So that's where you're going to set up like your leaderboard IDs and so forth. And once you've done that, all of the functionality is just going to be there live for you to use. So you'll be able to use things like Blueprint nodes to send up achievements, get achievement lists, see how far along you are along the achievement path. So real quick, I want to mention, we've talked a little bit about Match 3. I think Alan was talking about that earlier today, and he was going mostly over kind of the content side of how we built that. But this project is also going to handle a lot of online subsystem features as well. So it's going to handle things like achievements, leaderboards, game center and play compatibility, things like in-app purchases. By the way, I want to be super transparent now for when the game comes out. The in-app purchase is going to cost 99 cents because we couldn't make it free. We tried to make it free. You don't have to buy it. We're actually not encouraging you to buy it. It's just there so that you know that you can do it and to show you how it's done. So before the entire internet jumps on with us releasing a training game with in-app purchasing, it's just there to show how. That's it, I promise. So it also shows how to handle things like ad support. We're going to be releasing it on the App Store and Google Play as well, so you'll be able to download it and play it on your device. It's super addicting. But I did want to take just a moment and jump over to the engine. So here is the Match 3 project. And if we take a look inside the blueprints for it, there's the global game instance blueprint. If we open this up, and I don't know how well the text is actually going to read, so some of this you may or may not have to kind of take my word for, but what I'll do real quick is in the Find Results window, which is basically your Control F for blueprints, so programmers can kind of rejoice because it's pretty easy to find things. We can just type in achievement or something close to it and press Enter. And then we can jump right to some specific nodes that are just for taking apart achievements. So here we have check achievements. It's just grabbing an index from an ID that you set that kind of thing up on the back end. Here we are, get cached achievement progress. So how far are you along the path of getting a single achievement? And again, this is pretty much the same thing you would do in C++, again, just broken out visually. The point is, once you get all of that back-end work done in Google or iTunes, it's easy enough to access the key functionality you need to make these kind of things happen. And once we release the Match 3 project, you'll be able to take it apart and learn and see how we did it. Now, Demo, tilt game. So another thing that we kind of already talked about just briefly is we give access out of the box to sensors on your phone. Now, at the moment, all we really have access to is the gyroscope in your phone. If there are more peripherals in your device that you're interested in, let us know online. We don't really get a lot of requests for some of the other things, but maybe in some future it'd be cool to have access to things like the camera and whatnot. So what I want to do is take a look at this game that we kind of looked at earlier. So some of you might recognize this, right? It's just like your basic wooden labyrinth game. And what I want to do is show you how to get this fired up and working using a mobile device. Now, one of the mobile design elements I wanted to mention this morning, and I think I actually skipped it, is that we have an app that you can download, currently for iOS only, called UDK Remote. It's actually been around since the Unreal Engine 3 UDK days. And what it allows you to do is to connect wirelessly to your computer for the purposes of mobile development and testing. So let's jump into the blueprint for this game. I'm just going to hit Control-E, by the way. If you ever write down shortcuts, that's a handy one. It opens up the editor for whatever it is you have selected. And here is, if we jump out here, here's all of the math and code and everything that's making this happen. So I have a little collapse graph. Let's pretend we don't care about this anymore, because right now I kind of already have the game working. So we're going to basically break the game and put it back together so that everyone can see how this is done. Now, I want to preface this real quick. Because we're handling controls, we're going to be connecting everything up on tick. Now, I asked earlier today, but I've already forgotten. How many programmers are in the room? Lots of you. How many of you just got scared that I said I was going to access tick in a scripting language? Most of you. So generally, this is good for prototyping. If you wanted to do something on tick and you wanted to check it often, I would probably recommend that before you release, this gets moved over to C++, but your mileage may vary. So now I have some stuff already set up just to make things a little bit easier to follow, right? So we're doing some things in the blueprint like getting the ball's position the moment we begin. So instead of respawning, we're just kind of teleporting the ball back in case you fall out the board and die. We also have a test UI already set up. So I want to show that to you real quick so you can kind of see what we're up against. So if I hit play and open this up here in the mobile previewer, and of course it's going to ask me to save. We'll let this kind of do its thing. Now remember, the mobile previewer allows you to simulate touch events using the mouse. So if I click, that's the same thing as a touch. And so that's just turning on a really quick UI that I slapped together so that we can gauge our tilt values. Now, I'm currently sending this over the network here. So as I tilt my phone, you'll notice the values are changing. And if I touch my device, we can turn that on and off. So touches are actually being sent wirelessly over, which is pretty cool. So this is really just here to kind of debug which axes represent what. Like when I physically turn the device this way, what numbers are changing. Now, as a quick note, if you're doing this at home, the UDK remote values and the actual access values you get out of your device when you deploy may be different. So please make sure you're testing on device, and you may need to swap out access values when you go from one device to another. So in this case, we have side-to-side tilting, which is being handled in X, and we have Z tilting, which is being handled like so. So let's get that and let's hook it up so that we can drive our game. So I'm going to go ahead and close this out. Let's go back into the blueprint editor. And we don't need this guy. All right, so there's a few things we could do here. We could drive the whole thing on an input specifically for tilt. That's actually how our UI is fired. So there is an event that exists already called tilt. This fires on every tick, and it outputs the tilt axis value. We're not really going to use that. We're just going to drive everything straight off tick, and let's just say we get that tilt value for starters. Now this just gives us a vector. So how are we tilting in X, Y, and Z? I'm going to right click and just split that out, so now we have individual access to X, Y, and Z. Now earlier, when we were tilting, we can take a look at the numbers. I could open it back up, but it was going between -1 point some numbers and +1 point some numbers. So let's use that knowledge, and we'll just start off by getting X working, and then we'll branch out from there. So what I'm going to do is take the X tilt value, which is the side-to-side on my phone, and we're going to clamp that. So let's clamp it between -1 and 1. So we're doing a little bit of limitation here. Then after we've done that, now there's a lot of ways to approach this, just in case like you're thinking, why did you do it this way and not another way? There's a lot of ways to play with numbers. But if you have a different way in your head you would have done it, that would probably work too, because this is just like a scripting language. So now we're going to take this and multiply it by the actual rotation value that we want in degrees. So we'll just say multiply a float by a float, and let's say we multiply it by 20 degrees. Now we just need to pipe this into the object we want to rotate. Now our board is built of a few different parts. I can open this up here in the blueprint preview viewport. And we have the outer frame, which you can see kind of get highlighted, and we have the inner frame. Now, I don't know if you ever played with one of these at home. I used to have one. I actually broke it trying to play with it with my cat. But you had an outer frame that would rotate on one axis, and then you had an inner frame that would rotate on another axis. So we're going to build it exactly the same way it works in the real world. We're going to start by rotating the outer frame in X, and then we'll rotate the inner frame in Y, and everything should just work. So let's go back over to our event graph. And we want to talk to that outer frame first. So I'm just going to drag and drop that right into the view. And we want to access rotation. So I'm just going to type in rotate and see what it gives me access to. So this is thank you for being in the audience today. So this is a sensitive list that allows you to only see the things that you need access to right now. And we're going to change our world rotation. So let's use set world rotation, like so. Now, what are we going to set this to? Well, we need just access to the X rotation. I'm going to right-click and split that struct pin out as well. So rotation is just 3 values, right? It's rotation in X, Y, and Z. So let's just plug this straight into X. Now you might have noticed, now this is just for those of you out there who are totally new to the world of Blueprint. We got a lot of wires, a lot of connections here. So while I don't want this to turn into a complete beginner level course, anytime you see a colored wire, that's just moving a type of data. Anytime you see one of these great big thick wires, this is controlling your execution flow. So what we're saying is, on every tick, we're going to set the world rotation of the outer frame object by whatever math we managed to come up with here, which is getting the tilt value, clamping it, multiplying it by 20. So with all that, let's compile, let's save, and let's see what happens, and hope I didn't break anything. So here it goes. And probably be a little bit laggy, but hopefully not too bad. And boom. Up. Okay, it's a little bit of lag going on there, but that's network lag. When you do this kind of thing at home, it's probably going to be super smooth. That's me taking a pot shot at GitHub's network. I'm just kidding. It's working great. Okay, so here's the thing, though. There's a little bit of, it's a problem that you probably will run into, right? So when you're tilting, your hands might shake. You might have had as much coffee as I have. And then playing a game like this becomes impossible because you're doing this the whole time. So we're going to fix that as a part of our gameplay. Now, about a year and a half ago, one of our senior programmers, Jeff Ferris, wrote a really good blog post about the magic of Interp2. And it's like one of my favorite things we ever released to the world. So what we're going to do is create an interpolation setup that allows us to kind of interpolate toward a target rotation instead of just taking the raw rotation straight from the device. So to do that, let's just right-click out here in space, and we'll type interp2. And we have a lot we can choose from. Now, we're handling float data, so we're going to use f-interp2, and I'm going to use the constant version. So it's a constant interpolation, no ease in or ease out. So our target, we have current, target, we have delta time, and the interpolation speed. Target is where we want to go. Current is where we are. Delta time is the time between frames. And then interp speed is how fast you want the interpolation to go. So we're going to take our little math equation that we've made here, and I'm going to condense this so I can keep a little bit more of it in the screen at the same time, because I think it might help you remember some of this. We're going to plug that into our target. But we also need access to our current value. So let's take the return value here, and we're going to promote that to a variable, which we will call xRot for now. Now, that's setting a value, so that has to be part of our execution flow. So I'll connect that in with white wires like so. But now I can take that xrote value I just made, and that can be the current. So now we know where we are. We know where we want to be. We need to plug in delta time. There's two ways we could do this. We could just take delta seconds off tick and plug it in. But then my OCDs kind of start to twitch out a little bit because I have wires crossing everything. So there actually is a node called get world delta seconds, and it does the exact same thing. So boom, so now we have delta time. Now we just need to designate our speed. So I could go back and forth and test this over and over again, and you guys would get almost as bored as I would be. I'm just gonna set it to the magic number of 10. So your mileage may vary if you were building a similar system. So we'll compile, we'll save, and we'll play right here inside the mobile editor. And let's see how this goes. Still doing okay on time. If I'm talking fast, it's just to make sure we stay on something like a schedule. Okay. Oh, what did I break? I broke something. I didn't attach, look at that. I completely disconnected the rotation, and then I never sent it anywhere. That's horrible. You guys should boo me. Yeah, right? That's a little harsh, though. I don't know if I deserve that. Rough crowd. Okay, so let's try again. This time with more working. Okay. And go. All right, awesome. So now we get nice, smooth rotation, and it just shows how bad I am at this game. But notice we've lost a lot of that jitter. So Interp 2 is going to kind of help us out here, which is nice for testing on a wireless network, which might have some lag, but it's also nice for the device. Taking that raw data could be a little risky, so we don't really want to do that. Okay, now we need to do the same thing in another axis for a different object. So we're going to be using the Z-axis, not the Y-axis. That's just because this thing actually supports full 3D rotation. So it's doing this way, and this way, and this way. So I think that's the compass. But now let's do the exact same thing. And I'm all about cheating. Like I think you guys, some of you programmers out there are the same way. Don't write the same line of code twice if you can write it once and reuse it. So let's take the mathematical part of this, where we've got the clamp, we're multiplying by value, we're getting out our interpolation, and that's all good. Let's just take all this, and I'm going to right-click and convert this over to a macro. So macro is nice for a snippet of reusable script, or code, they work the same way in code, that you'd like to access again. And the nice thing about putting this into a macro is if we make a change to the base version of it, it'll update everywhere. So let's call this interpolate tilt. And that'll be our special custom macro. And then we can start making our graph look even prettier, which I like that. Okay, so now let's just take that, Control-C, Control-V, and we just plug some stuff in, right? So we take Z and we plug it into value. We need to figure out what our current is going to be, right? And we'll do the same thing. We've got to store that. So let's just right-click on the output. We'll promote that to a variable. We'll call that zrote. And we need to get that also in line. So we'll just put it up here. And I just start kind of, honestly, if I was doing this, I would probably use a sequence node, but we won't get too crazy right now. So we'll plug this into the Y. Well, actually, we're not going to touch that at all. Ignore what I just said. We need to talk to an entirely separate object. Remember, the first thing is we're rotating the outer frame, and then we want to rotate the inner frame on a different axis. So let's go get the Unreal Labyrinth, which that's going to be our actual game board. And now we want to set its rotation. But this is a little different. In this case, we want to set the relative rotation. That way, it follows along with what its parent was doing first, and then we apply rotation from that point. Does that help when I do that? All right, so we'll choose set relative rotation. We will split the struct open so we have access to X, Y, and Z individually. And we're going to take our zrote and plug it into Y. Now just make sure these guys are all wired up in series. So, I mean, it's starting to get a little zigzaggy, but overall, not too hard to follow. We also need to make sure we take Z rotation and use that to drive our current value. So we can just drag that right over the pin, and Blueprint will take care of the rest for us. Okay, so let's compile, let's save, and let's hit play. And my phone went to sleep, which is awesome. right, here we go. By the way, this isn't going to work, and well, it's not going to work perfectly, and you guys won't be able to see why immediately. So tilting left and right is working as expected, but tilting up and down is actually reversed. It's just how the numbers work. There's nothing we could have done about that, but we can fix it really, really easily. All we need to do is take that return z value from the tilt, and let's just multiply it. I know where my asterisk key is. We'll multiply it by -1 and plug it in. And now if we compile and save, everything just works. And here we go. Cool. So now you can see, you guys can watch me really, really suck at this game. But there you go. So just like that, we were able to read in sensor data from our phone and then use that to drive a game using Blueprint. Now, again, based on your performance, you should be testing this kind of thing on device, and depending on your min spec or what device you want to send out to, you might, at the end of the day, want to convert this over to C++. But on the flip side of that, the good news is that you now have a functioning flowchart that tells you exactly what to do with the numbers and where to get them. Okay, so are there any questions about that before we move on? Yes, sir. Yeah, hang on, let's get Joe out here with his magic microphone.
How come your OCD filter didn't go off when you plug Z into Y?
Don't do it. Don't. So, because time and demo, right? Because like I would love to do this where no wires crossed, and honestly, sometimes you can't do that, and every time I die a little inside. But for time and happiness value, we're just gonna kind of blast through it. Great question, though, really. Any other questions?
Hi, yeah, I was just wondering if there was a reason to prefer a macro versus a function.
Sure, there is actually. If no other actor or object in your game ever needs to call it, then there's no reason for it to be a function. So you can break it down like this. There's 3 different ways to collapse a node. And I can show you as well as tell you, right? So if I grab any selection of nodes and right-click, you have 3 things that you care about. You have collapse nodes, you have collapse to function, and you have collapse to macro. So collapse to nodes, use this if you are never going to reuse that snippet of Blueprint graph anywhere, and you're just trying to make things look tidier. If you want, like you take your entire game and crush it down to 1 node and call it the My Game node, if that makes you feel good, that totally works, and it irritates everybody on your team, but you can do it. But only if you're never going to reuse it. Now, if it's just going to live inside this blueprint, but you are going to reuse it, like this math equation we came up with, then a macro makes sense. Because if you screwed up the math and you did it wrong, you can just open up the macro, fix it once, and it applies everywhere. If you had done that with collapse to just collapse the graph, you'd have to go change it on every single copy-paste, which would be horrible. Now, collapse to function is something that this object could call. So if you wanted to, you could make a function call here within your blueprint. So if you know you need to do that, function might be the way to go. But also other actors in your scene could call it as well. So if you know that you've just made this important block of code that other things are going to be able to need to access, then it's possible that collapse to function is the way to go. Does that make sense? Cool. Any other questions? Okay, so let's move on. So I'm going to jump back to my slide deck for just a moment. So really quick overview, probably everybody in the room knows this at this point. ES2 is forward rendering, right? So it's not the deferred renderer by default that you're using when you're building for PC. The Perforce and GitHub builds of the engine are going to give you access to the ES 3.1 AEP build. So if you want to actually use deferred rendering on high-end mobile, you can do that. We have not enabled it in the binary. Programmers probably get why. It's really just a way to keep people from accidentally turning something on which kills performance. So for right now, we've made it a little harder on you to do. Now, we're going to look at some new features. Now, some of these have dropped in 4.9, so you can play with them right now. Some of them are coming in 4.10. So mobile decals are one of these. So traditional decals in UE4 are really just writing data into the G buffer prior to render. So if you want to do like a stain decal, which is changing the color, that's just sending some data into the base color. If you want to use normal to add cracks on the floor, that's just adding something into normal, and then everything gets lit and it renders and it's all happy. The problem though is that's really tricky to do in the forward rendering land of mobile. You don't have those buffers to write any data to, and all of the lighting is done object by object. So what this means for you is that decals are going to be unlit on mobile. That's just how it is. So to manage this, some of the decal types have been changed a little bit. So the stain decal is going to modulate. It's just going to multiply whatever color is there. And then emissive is just like an additive. So let me jump back over to Unreal real quick, and I'm going to change out projects. I'm going to open up what is probably my very favorite project in all of Unreal Engine 4, and if you haven't grabbed it, you should, and that is our Content Examples project. There's so much to learn in this project. It's available for free in the Learn tab, and what it is a library of individual levels in a single project where each level showcases a different feature of the engine. We're always working on it. We're always looking for new things we can add to it. It doesn't cover absolutely everything, but it covers a lot of stuff to help get you off the ground, so can't recommend it enough. So this is the decals level, and you'll see these are kind of broken down with individual stands that you can walk to, kind of like a science fiction museum. Also, just a really quick thing here, you'll see these little kind of rotating, they almost look like quest markers from an MMO. Whenever you see these inside this project, you can click on them, and that will open up the documentation over here in the details panel. So this will take you right to our online docs telling you how this thing was built. Okay, enough blurbing about that, but you should use it if you haven't yet. Now, what I'm going to do really quick to show you how decals work is I'm going to switch out our renderer here in the viewport. We're going to switch over to the ES2 renderer for iOS. Give that a second to process, and notice what happened to that decal. So we went from something that was nicely changing the color to something that isn't quite so nice. And it's probably going to be a little easier to see here if I jump back and forth on this stand. So we'll give that just a sec. So you can see here's a translucent decal, there's stain, there's emissive, there's normal, adding a nice little bit of bump into the object. But the moment we start rendering at the forward rendering ES2 level, we lose a lot of these features, right? So this is just the way they are right now. That's how it goes. But you have some options, and some of these we actually covered a little bit earlier today. I'm going to kind of run through an example really, really fast because we saw a little bit of this earlier this morning. But here is an example decal in Shader Model 5. You can see it's got some normal. It's kind of metallic, looks very cool. And then as soon as we switch over to ES2, it's kind of boring, right? So this is where things like the feature level switch are going to come in really handy, and it does work on decal materials. So if I open this material up really quick, I'm going to do this like in a dirt, simple, down and dirty way, and I think I actually grabbed the wrong object here, so let me make sure that I've got the decal. There we go. That's the one that I want. So let's change this really quick. I'm just going to make a quick make material attributes. Also, quick shortcut for those of you who didn't know is here. You can replug any wire in the editor with control. So notice this guy's plugged into the normal map. We'll just hold down control and just replug it in down here. I always feel like I'm hooking up stereos when I do this. Cool. So this will be our standard Shader Model 5 version. And then let's make another one. Let's make like a really, really simple version, right? So we'll steal the base color, because that probably works well. We'll steal the same opacity, because that'll get the thing cut out, and that's good. And then, actually, you know, for base color, let's do like a really nasty old school hack to get a little bit of depth back into it. Let's grab like the green channel of our normal map, and we'll add that back onto the base color, which is going to look like a really cheap kind of emboss filter, but it's better than nothing. So now we just need to do that feature level switch that we talked about earlier today. So we'll let our high end be the default, and that'll be the Shader Model 5 as well. And then for ES2, we'll use this little fancy one that we put together. Let's compile that. Give that a second to save. Awesome. And I killed it. I destroyed it all. I've ruined everything. Oh. This is what presenting live can do for you. It can do it to you too. So let's cut that. Let's make sure that we set this over to just use material attributes, right? Because we just plugged all of that data into base color. So that black screen, that's kind of Unreal's very special way of laughing at you. So we'll plug this in. We'll recompile, pretend that none of what you just saw actually happened. And there we go. So now we can save this. And if we let that finish doing its thing, we can jump over here. And now we have our special ES2 version, which is unlit, but still has a little bit of bevel shape to it. And just in case you want to see that just one more time, if I switch back over to shader model 5, here's the full rendered version where I broke the normal map. So that's a really quick look at mobile decals. Again, the only thing you're really having to deal with is that they are unlit because there's no G buffer for them to write data into. So your artists are going to have to play with that a little bit. Now, another feature, if I jump back over to my magical slide deck, which lives somewhere that I might have closed. It's fine. We didn't really need it anyway. So we're going to take a look at what are called character shadows. These are a way to get shadows back on your dynamic characters in your mobile projects. So to show this off, I've got a project kind of waiting in the wings here. We'll take just a second and load that. Now we don't need that open anymore. There we go. And what this is just basically our third-person example, right? Straight out of Blueprint. So if I take this and switch over to ES2 rendering, you'll notice that by default, I lose all of my shadows, right? So what we've set up for character shadows now is you can take a single directional light and you can tell it to cast modulated shadows. Now, these are very similar to the modulated shadowing that we had in Unreal Engine 3, but it does add a dynamic shadow that will follow the character around. Now, kind of a nice upshot to modulated shadows is that you can change their color. So if I want to, I don't know how well that shows up on the projector, but you see kind of a green shadow and kind of a red shadow. I probably should get like right down on it. That might help. I think green was showing up better because light. But another thing you should be aware of, or at least your artist should be aware of as well, is that these are not going to mix, right? They're just going to modulate over the top of one another. So just be aware of that. For example, if I grab a basic object like a cylinder, let's drag it into the world. So it has a shadow too, which is great. But if, and actually, let me jump back over to shader model 5 for just a second. So you can see the difference, right? These obviously look a little bit better, but it's nice getting to have some shadows. But what I'm going to do is make these shadows kind of overlap one another. And now when I turn ES2 back on, you can see that they're not mixing super well, right? You get one multiplied by the other. So they're going to keep darkening. It's just a limitation. Be aware of it. But again, you've got the ability to have nice, crisp shadows on your dynamic objects. Okay, so I think what I ended up doing was I closed out my slides. So you'll have to forgive me for just a second while I open those back up. I feel like I should like cover my screen up. As a quick aside, for anybody who is interested once the demo is over, I actually have that Labyrinth game on my phone if you want to check that out. It's what happens when you hit the close button, right? Okay. So last thing really, just a quick mention of Metal and Vulkan, the new mobile APIs. The idea here is that these are approaching the same level of efficiency as console. Right? Now they're going to give you less overhead, more direct GPU control. Metal iOS, just iOS, is already supported in Unreal Engine 4, so you can start playing with it today. If you have specific questions over these APIs, you should definitely hit Smetis up, who's going to be talking right after this talk. So that is my entire demo. A couple of hitches aside, but they keep things exciting. Are there any questions about anything, in like any of the rendering features or anything I've talked about up to this point? None. Okay, so thank you all very much.